Okay, so we're going to do an exam review. One of the things I want to point out, we're going to do the in-class review. This is what I would normally do if we were face-to-face. And you need to turn in the one that's the exam one review that doesn't say in-class, and it also tells you that it's worth a daily quiz grade and up to 5 bonus points on the exam. You need to work it neatly and in order on separate paper. That means don't work it on here. Get out some notebook paper and write it out just like I write out over here. It has to be submitted as a single PDF document. So that means you're going to have multiple pages of writing and you're going to submit it as one PDF document into D2L before you take the exam. It has to be submitted before you take it, not after. So make sure you work this one, and there is a key on the back so you can know if you're getting to the right answers. You can't just write the key, though. You got to show your work in order to get the credit. And how that works is if, let's say you only do 10 questions out of 14 questions total, then I would figure out 10 divided by 14 equals a percentage. If you do all 14, then you get 100% as your quiz grade, and you'll get 5 points. All right, so this is our in-class review. First question, we're going to find the mean, median, and mode for the following distribution. All right, so let's look at example 1. So we've got to find the mean, the median, and the mode. What I'm going to do first of all is I'm going to put them in numerical order. For the mean, I don't have to, but I'm going to go ahead and do that. So that way it'll be easier to find our median and our mode. So we have how many numbers? 1, 2, 3, 4, 5, 6, 7 numbers. So we have an odd number. So our numbers in order are going to be 3, 5, 5, 6, 7, 8, and 9. Let me write up here. This is the exam review 1. All right. So those are the numbers that we're dealing with. If I want to find the median is going to be the middle number. Remember, think about the median in the road. So we've got 7 numbers, so probably the 4th number in. So as we mark it off, it'll be that middle number right there. This is going to be our middle number. There's 3 on either side, so the median is 6. Remember that the mode is the one that happens the most often. 5 is the only number that repeats, so our mode will be 5. And then we need to find our mean. The mean is the same thing as the average, so we're going to add the numbers together. You don't have to do this in numerical, but since we have it that way, I'm just going to do it. So 3 plus 5 plus 5 plus 6 plus 7 plus 8 plus 9. And we have 7 numbers, so we'll divide by 7. This will get us 43 divided by 7, which is 6.1. So there are our 3 answers for problem number 1. All right, number 2. So for number 2, we are looking at probabilities. So if the probability that your television breaks before the extended warranty expires is 0.015, what is the probability that it won't break? So we have to remember, let me pull this out just a little bit so you can read the whole question. We have to remember that all the probabilities equal to 1. So we're going to have, for part A, we'll have 1 minus that decimal of 0.015, which will get us 0.985. For part B, it says there's a 1 in 5 chance that it'll be sunny this weekend. What is the probability that it won't be sunny? Again, all of the probabilities add up to be 1. So this will be 1 minus 1 out of 5, which would be 1/5. I can rewrite 1 as 5 over 5. So I get a common denominator, and that'll get us 4 out of 5. So there's a 4 out of 5 chance that it will not be sunny. All right, let's go on to C. So for C, assume that A and B are events. If the probability of A equals this, if the probability of B equals this, and the intersection equals this, find the probability of A union with B. So this has a formula where the probability of the union is equal to the probability of each event, so probability of A and the probability of B, minus the intersection, because the intersection is where they're going to overlap. So here we just need to plug in our numbers. The probability of A is 0.40. The probability of B is 0.55. And we were given that the intersection is 0.25. This will get us an answer of 0.70. That is the probability of the union. All right, let's look at D. So D says, a card is drawn from a well-shuffled deck of cards. Find the probability that the card is a club or a six. So that's using the same formula we just did. So we're having the probability of a club union with a six because it's an or, and would be intersection, but or is union. So we're looking at the probability of a club plus the probability of a six minus the intersection of a club and a six. So this is where you have to remember how many cards are in a deck, how many suits are there, how many cards are in each suit. You also need to know that half of them are red and half of them are black. So the probability of a club, there are 13 clubs out of 52 cards in a deck. For each suit, there is one of each card. So there are 4 sixes because there are 4 suits. There's club, spades, diamonds, and hearts. So plus 4 out of 52. There is only 1 6 of clubs, so minus 1 out of 52. This will get us 13 plus 4 plus, or minus 1 will leave us with 16 out of 52. And then this will reduce down. If you don't know what it reduces, they're both even, so we can divide by 2. And that would get us 8 out of 26. I can divide by 2 again. 8 divided by 2 would be 4. 26 divided by 2 would be 13. Or you could divide them both by 4 and done it in one thing. You always have to reduce. All right, let's go to E. E is an experiment consists of rolling 2 fair dice and adding the dots on the 2 sides facing up, assuming each simple event is as likely as any other. Find the probability that the sum of dots is 7. So we've got to figure out. So we're using 2 dice. We're not, when they just say 2 fair dice, they don't mention they're a 6-sided dice, versus if they're looking at an 8-sided or a 12-sided, they're going to tell you. So if it just said fair dice, then we're talking about a 6-sided dice. All right, so let's find the set first that will add up to be 7. I could have a 1 and a 6 will get me to 7. If I rolled a 2, I'd have to roll a 5. If I rolled a 3, I'd have to get a 4. If I rolled a 4, I'd have to have a 3. If I roll a 5, then I need a 2. And if I roll a 6, I need a 1 to equal to 7. So this is the set of outcomes where the 2 sides add up, the sum of them add up to be 7. So the question is, again, assuming each simple event is likely, find the probability that the sum of dots is 7. So this is where we have to remember how many total outcomes are there. And it comes from the fundamental counting principle. If we have 6 sides on each dice, 6 times 6 will get us 36 possible outcomes. So if we have 1, 2, 3, 4, 5, 6 outcomes, that total to be 7, it'll be 6 out of 36. They both divide by 6, and we end up with 1 over 6. All right, let's look at F. For F, an experiment consists of rolling 2 fair dice. Adding the dots on the 2 sides facing up, assume each simple event is likely as any other. Find the probability that the sum of dots is less than 6, so not equal to 6, but less than. All right, the lowest way that I can roll, I could get 2 1s. That'll be equal to 2. I could get a 1 and a 2 would be 3. A 1 and 3 would be 4. A 1 and 4 would be 5. And I can't go 1 and 5 because that would equal 6. So we need less than 6. All right, what if I roll a 2 first? I could roll a 2 and a 1, a 2 and a 2, and a 2 and a 3. Because that again equals to 5. That's 4 and that's 3, so we're less than 6. All right, if I rolled a 3, I could roll a 1, and I could roll a 2. And then if I roll a 4, I can roll a 1, and that totals to 5. I can't even roll a 5, because then anything else would be equal to 6 or greater. So that gives me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible outcomes out of those 36 possible outcomes that we already discussed. These will both reduce by 2, and we end up with 5 over 18. So that's dealing with the probabilities. Okay, the next thing we're going to look at is example 3. And example 3 says a store carries 4 brands of televisions. From past records, the manager found that the relative frequency of brand choice among customers varied. Would the following probability assignments for a particular customer choosing a particular brand of television be rejected or accepted, and why? All right, so this is example 3. Now, for store A, we have this probability, this probability, this probability, and this probability. We've talked about that in our class, that all of the probabilities have to be equal to 1, and also that the probabilities have to be positive. So for part A, because the probabilities have to be between 0 and 1, we would have 0.29 plus a negative 0.14 plus 0.37 plus 0.48. Now this totals to be 1. The total probability is 1. However, this one will be rejected because of a negative probability. All probabilities have to be positive. Okay? That negative right there means it won't work. All right, let's look at B. So we have 0.17 plus 0.32 plus 0.26 plus 0.25 equals 1 as our total. This one will be accepted because, it will be accepted because it totals to 1 and it is positive. Apparently my green pen is just going to be sad. It's got lots of ink, but it's not going to work. So it's going to be accepted. Probability equals to 1. All right, let's go to C. Here we have 0.63 plus 0.23 plus 0.18 plus 0.29. All of our probabilities are positive, but when we add them, we get 1.33. So this one, again, will be rejected because the total is greater than 1. Okay? So we're just adding the probability numbers in the list. All right, let's go to example 4. So for example 4, a tire manufacturer produces 80% of its tires at plant A. If 6% of the tires manufactured at plant have defective tread, What is the probability that one of this manufacturer's tires was manufactured at plant A and has a defective tread? So here, plant A, 80% are there, 6% of the tires manufactured at a plant, because they have more than one, have a defective tread. So what is the probability that the tires were made at plant A and have a defective tread? Well, we're going to take our probability times our x value again, like we did in one of our sections. So we're going to take our 0.80 times 0.06. Notice I changed the percentages to decimals to do our math. So 80% becomes 0.8 and 6% becomes 0.06. And that will get us 0.048. And there you go. And if they were asking for it, typically I'm good with this. If you wanted to change that to a percentage, because it's just looking for the probability, it's not asking for a percentage. Okay, it just says what's the probability. This would be the probability percentage. It would be 4.8%. So pay attention to what it's asking for. All right, number 5. An unfair coin is flipped. If a head turns up, you win $1. If a tail turns up, you lose $1. The probability of a head is 0.59. The probability of a tail is 0.41. Let x be the random variable for the amount won on a single play of the game. What is the expected value of the game? All right, so this will be example 5. So we win $1 if a head turns up, and the probability of a head is 0.59. And the other part is that we lose $1 if we get a tail. So that'll be a -1 times 0.41 for the probability of getting a tail. This will get us 0.59 minus 0.41, and it'll equal 0.18. So that is our expected value, would be 18 cents. All right, let's go to number 6. So on example 6, we are given the probabilities and values associated with the 5 outcomes of an experiment. Calculate the expected value for the experiment. So here we have the probability. There is our x value. We're going to multiply them and add them. Do not be short with this and go, oh, I'm just going to put little plus signs. Write your math out. When you're taking a test, you want to show the work and not leave anything to, well, is she going to accept that? Don't give me chicken scratch. So 0.5 times 3 plus 0.1 times 6 plus 0.3 times -4 plus 0.6 times 7. Probability times our x values. 1, 2, 3, 4. Yep, it says 5 outcomes, but there's only 4, so I guess there's a typo there. All right, this will get us 1.5 plus 0.6 minus 1.2 plus 4.2, and that will get us 5.1 as our expected value. So our expected value is equal to that. All right, so our next problem, number 7. We're moving away from our probability parts, and now we're moving into the algebra that we learned. So we're going to use the given conditions to write an equation of a line. First one is passing through these 2 points. We need to write the equation of a line. There's a couple of formulas that will go with this. So this will be example 7. If we're writing the equation of a line, we're going to have y minus y1 equals m times x minus x1. And then we reduce that down to y equals mx plus b. For the slope, the m, we have m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So here comes your first question. Will the formulas be given to you on the exam? They will be. They will be listed somewhere on the exam. Usually it's on the first page. They will not be labeled, so you need to know what they are, but I always provide formulas because I want to know if you can choose the right formula and know what to do with it, not if you can memorize them. All right, so for part A, we have a point at negative 4, 3 and negative 2, negative 7. So this is going to be our x sub 1, y sub 1, x sub 2, y sub 2, because this is our first point, that's our second point. It doesn't matter which point you put first and which one you put second, it'll all work out. I am not given a slope here, so the first thing I have to do is find the slope. So my slope will be my y sub 2 minus my y sub 1 over my x sub 2 minus my x sub 1. Don't forget the minus signs that are part of the formula. This will get us negative 7 minus 3, which will be negative 10, and negative 2, that double negative there becomes the positive 4, so that'll be divided by 2, which will get us negative 5. So that's our slope. Now we're going to pick one of the points. It doesn't matter which point you pick. It will work out to the same answer no matter which way you go. So we have our slope, and I'm just going to use the y1, x1, y1 that we chose at the beginning. So I'm going to have y minus my y1 of 3 equal to my slope times my x minus my negative 4. So that'll get us y minus 3 equals negative 5 times x plus 4, because that double negative makes it positive. So y minus 3, negative 5 times x is negative 5x. Negative 5 times 4 will get us negative 20. We'll now add 3 to both sides. So y equals negative 5x minus 17. This would be the equation of the line, but you're going to have to find that slope in order to do part A. All right, our next question is part B, and it says passing through the point, and the slope is 0. So this will be part B. So we have a point of negative 4, 3, and our m is equal to 0. Now, because our m is equal to 0, if I plug this in to my y minus y1 with our m right here, if m is 0, all of this goes away. So this is where we can remember that if we have m equal to 0, our slope is 0, then that tells us we're going to have a straight line. It's going to be a horizontal line. Now you can plug it all into the y minus y1 if you want to. You can plug it into that, and that would all equal to 0, because anything times 0 is 0. Or if you understand that the slope is 0, it's going to be a horizontal line. And a horizontal line is y equals, and our y value is 3, so it'd be y equal to 3. Now on part C, we are given that it passes through the point of negative 4, 3, but our slope is undefined. If it's undefined, an undefined slope is a vertical line, and so we're going to have a vertical line, and a vertical line has an x equal, so it'll be x equal to negative 4. You won't have a number you can plug in because it's undefined, so it's just an x equal graph. That's just to help you review for the different types of situations with equations of lines. All right, so that takes care of number 7. We're on to number 8. So number 8, we are looking to find the domain of the function, and we need to write it in interval notation. You need to make sure you understand what interval notation is. So we are given for part A, g of x equals 5x over x minus 7. So if we're looking at the domain of the function, that means that we're looking for things that will cause it to be undefined. There's 2 things that can cause us to be undefined. One is we can't divide by 0, and the second one is we can't take the square root of a negative number. So we have to look for the numbers that, in this case, because we don't have a square root, we're not worried about that. But we're looking at x minus 7 as our denominator. We're going to take x minus 7 equal to 0 and end up with x equal to 7, because we'll add 7 to both sides, get x equal to 7. So what that means is our domain can be any number except 7, because if I plug in 7, I get 7 minus 7, which is equal to 0. So that means I'm going to find my interval notation. I find the easiest way to do this is to graph. I'm going to start with a graph of negative infinity to infinity, and I'm going to put that 7 in there. Now my interval can be any value except that 7. So that means it can't be equal to the 7, but it can be everything less than 7 and greater than 7. So my interval notation will be negative infinity to 7 union with 7 to infinity, and it has parentheses because on the 7 because we can't equal it. We can't do a bracket because if we have 7, we end up with 0 in the denominator. This would be the interval notation that you would be looking for. All right, let's look at B. B, we are given h of x is equal to the square root of 22 minus x. So this is where we're looking at, we can't take the square root of a negative. So we're going to take what's inside the radical and make it greater than or equal to 0. I can take the square root of 0. The square root of 0 is 0, so that's okay. But I can't take the square root of a negative. To solve this, I'm just going to add the x to both sides and get 22 greater than or equal to x. And then I'm going to do my interval notation again. I'm going to put my infinities on there. I'm going to put a 22. Now, x is less than or equal to 22 because it's on the small side. So x has to be less than or equal to, which means we're going to the left. And it's going to get a bracket because it can equal the 22, because 22 minus 22 would get us 0. And again, we can take the square root of 0. So this would get us negative infinity to 22 with a bracket. This would be our domain of our function. All right. Our next question is number 9. And on number 9, we're going to look at our graph and determine some items. Oops, a little too high. Sorry about that. All right, so the first thing we got to find is the domain. Then we're going to find the range. Is it a function? And then y. And then we're going to find f at negative 3. All right, so here is our graph. Let me zoom in just a little bit here. So we're looking at the graph, and we're looking at the domain. The domain is the x values. We're going to start on the left and scooch on over. Our graph continues to go up, so it's going to go from negative infinity to infinity. Because even though this is going up, it's coming down. Our x values can be anything. This is the negative side, so negative infinity to positive infinity. And it will be parentheses on both because that's what the infinities get. Now the range, as we're going up, our range starts on the y value. We start on the negative ones. And we come up, and the first point we hit is negative 2, and it continues to go up. So it's going to be negative 2 to infinity. Infinities always get parentheses, and the negative 2 will get a bracket because it's touching the line. Now, is this a function? It is a function because it passes the vertical line test. I can draw a vertical line anywhere on my graph, and it will only cross the graph one time. So yes, and I'm going to write passes vertical line test because I have a graph. It will pass the vertical line test. Now f at -3, I'm going to go find the x value at -3, and it touches the graph at the y value of -2. So that would be my answer because -3 is at -2 for the y. All right, we're going to flip over and do a few more problems. Our next one is number 10. Let's back it back out a little bit again. So for number 10, we are looking at evaluating the function of the given value and simplifying. So here's our function. So we have g of x equal to x squared plus 4 divided by x minus 5, and we want to find g at -3. So what that means we're going to do is we're going to plug in -3 into our function. So g at -3 is going to be -3 squared plus 4 divided by -3 minus 5. Now, did you notice that when I put the -3 in the x squared, I put parentheses around it because you have to square the whole number. If you don't put the parentheses, you might think that's actually -9. But it's -3 times -3, or -3 squared, which is +9. And then 9 plus 4, and then -3 minus 5, they're both negatives. You're going to add and keep the sign. So 3 plus 5 is 8. Keeping that negative will get us -8. So 9 plus 4 is 13 divided by -8, and that would be your answer for number 10. All right, let's go on to number 11. So for number 11, we are going to find f of x plus h minus f of x over h. H cannot be equal to 0. And we're looking at f of x equals to 3x minus 7. All right, so we are looking at f of x plus h minus f of x all over h. And our function is f of x equal to 3x minus 7. So the first step I want to find, let's change colors here. So step 1, I want to find f of x plus h. And what that means, if you recall from the last problem, we found g at -3. So that meant we plugged in -3. Here we want to find f of x plus h. So that means f of x plus h goes wherever the x's are. So this will get us 3 times x plus h instead of just x minus 7. Let's distribute our 3. We get 3x. 3 times h would be 3h minus 7. We can't simplify that any further. Now you can do this problem all at once, but I'm going to find our f of x plus h. Then we'll subtract our f of x, and then we'll put it over h, because I think it can be a little bit easier to do when we don't have as much going on. All right, so our next step, step 2, will be to take our f of x plus h and subtract our f of x. All right, we already know what f of x plus h is. This is going to be our 3x plus 3h minus 7 that we found on step 1, and then we're going to subtract the function. So we're going to subtract our 3x minus 7, which is our f of x. Now, if you noticed, I put that in parentheses because I have to subtract the whole thing. You don't want to just put minus 3x minus 7 because you have to subtract both parts. So this will get us 3x plus 3h minus 7 minus 3x Negative times a negative will get us positive 7. All right, to simplify this, we can see we have a positive 3x and a negative 3x. We have a negative 7 and a positive 7. This will leave us with just 3h. On this step, you should be left with only terms with an h. Step 3 is going to be f of x plus h minus f of x all over h. Well, we already found this top part right here. Gets us 3h over h. And that will be equal to 3 because the h's will cancel. And again, you could put it all together in one problem and then reduce it. Or you can step it out, whichever way you like. But that would be your final answer no matter which way you go. All right, let's look at number 12. So number 12 says find f at negative 2 and f at 3 for the following piecewise functions. So here I have to look at my piecewise function. For f at negative 2, am I going to use x is greater than negative 2 or x is less than or equal to negative 2? Well, at negative 2 has to be the equal. So on the first one, f at negative 2, we're going to use the x plus 5. So for f at negative 2, we will use x plus 5 out of our equation. So that means we're going to plug in that value for x. We'll have negative 2 plus 5, which will get us 3. Now for the other part, for f at 3, we're going to look at our function. And I need something that is greater than negative 2 to get 3, because 3 is greater than negative 2, so I'm going to use x minus 4. So this will get us 3 minus 4, which will be negative 1. So all you're going to do is plug in your value into the x part of the piecewise. Just pick the right part of the piecewise. All right, we are on to number 13. On number 13, it says use the graph of the function to graph the function g. Graph the function g. This is a key thing. A lot of students forget to do that part. Explain in words how the graph transforms or shifts. All right, so for transforming or shifting, so we're looking at f at x minus 2 plus 4, and this is actually g of x equal to that. Let's see, g of x equals f of x minus 2 plus 4. So we're looking at what's happening at the numbers. We got to tell in words first what changes here. So x minus 2 tells us that we're going to go right 2. It always looks like the opposite. You think subtraction, oh, that's going to go to the left. But it actually, when we did this in class, we found that it actually goes to the right 2. So the inside of the graph is going to do left and right, and this goes up and down. It's positive 4, so it's going to go up 4. If it was negative 4, it would go down 4. So those are the two words you're looking for. And then we need to actually do the graph on that. So I'm going to go right 2 and up 4 on each part. So I'm going to go 1, 2, right 2, and up 4. 1, 2, 3, 4. Over 2, and up 1, 2, 3, 4. Over 2, and up 1, 2, 3, 4. Over 2, and up 1, 2, 3, 4. And then I'm going to connect my dots. Don't forget to do that part of the graph. So that's what you should expect to see on exam 1. Make sure you study and make sure you turn in this exam review worked out. Don't just write the answer key. You got to work it out for me, okay? Now, if you want to include this page so I can see how you shifted your graphs and you don't want to draw the graph out, I'm okay with that part, but don't squeeze everything else in. It needs to be on paper.